Hello everyone, I'm Lucy Gunawan and today we're focusing again on the join operation. This video is the second and the final part of the lesson about join operations. During the course of this video, we'll use the TMDB database again to find the answers to some really cool questions about the movie industry. During the first part of the lesson about join operations, we saw many small examples of join operations. You can click here to go back to the first lesson if you want a quick refresher. This first video is a good foundation to understand how join operations are working, but our knowledge is still limited because all these examples were still very small and theoretical. Today is the second and final part of the lessons about join operations. Today, we apply our knowledge to solve some real-life use cases about the movie industry. To do so, we will once again use the TMDB 5000 movie database. So, let's start. Now, let's download the data we'll be using for this tutorial. Open Anatella. Click on the Help menu and select the Data Preparation Course for Beginner. And then choose the TMDB Use Case 3 option. First, let's organize our workspace. Create a folder named Tuto3 in your document folder and copy all the necessary files into the Tuto3 folder. You can always refer to the finished TMDB Use Case 3 file for this exercise if you need assistance. Let's take a look at the structure of the tables we'll be working with. Inside this lesson, we'll use 5 tables from the TMDB database. These 5 tables are movie, cast, gender, genre association, and genre. The first table is a table about movies. The first column of this table is the ID column. It's a primary key that is unique. The other columns describe the usual characteristic of movies such as title, language, popularity, release date, budget, revenue, and vote average. Next, we have the cast table that includes the foreign key movie ID that links to the ID column of the movie table. The cast table also has other columns such as cast ID, cast character, gender ID, and actor name. Next, we have the gender table with the column gender ID and gender name. The gender ID serves as a common key for joining with the table cast. In the same vein as the gender table, we have a second very simple table, similar to the gender table. It's the genre table. The genre table also consists of only 2 columns, genre ID and genre name. Finally, we have the genre association table that has 2 foreign keys, movie ID and genre ID. This association table allows to link 2 tables together, the movie table and the genre table. The first foreign key links to the movie table, while the second foreign key, genre ID, allow us to join with the genre table. During the course of this lesson, we'll be using many different tables. All these tables are stored inside GEL file from Anatella, so that it's easy to use them. Just drag and drop the GEL file from the Microsoft File Explorer window to the Anatella window. If you follow the previous lesson, the lessons about aggregation, you should already have a GEL file that contains a table with all the movies. If that's not the case, click here to quickly create this GEL file from the raw CSV file. Now, let's answer our first question. We want to compute the average cast size of movies in the Chinese language. To do so, we start by joining together these 2 tables, the movie table and the cast table. During the part 1 and 2 of this video, I already explained the join concept using the simple join box in Anatella. However, the simple join box can be slow because it requires sorting the data first. Anatella provides a more efficient box called the multi-join box. that is useful for left and inner join. The multi-join box saves time and computing power. Just remember that the primary key in the slave table must be unique for the multi-join box to work properly. Now, this means that we cannot freely choose the order in which we connect the table inside the multi-join box. Our slave table must have the key that is unique. Since inside the cast table, the movie ID column has multiple values, this table cannot be a slave table, so we'll put it as the main table in the multi-joins box. Once we have the join data, we can filter it based on the language. Specifically, we want the movies with Chinese as the original language. To compute the average cast size, we need to aggregate the data by grouping it by movie ID. For each different movie ID, we'll count the number of rows and this will give us the cast size for the current movie. After that, we perform a second aggregation to compute the average of the cast size across all the movies. So, Chinese movies have an average of approximately 13 cast members. As a bonus, let's compute the average cast size for all movies for all the different languages. To do so, we run an aggregation on movie ID and original language, and we just output the count. This count gives us the cast size. Then, we perform a second aggregation using original language as the grouping variable and compute the average count from the previous aggregation. Well, on average, English movies have the highest number of cast members. Let's plot it to make it more clear. For the second question, we want to find actors who portray both male and female characters. To do so, we must join the cast table with the gender table using the gender ID as the key. Let's drag and drop the cast table and the gender table inside Anatella. The cast table is connected on the first pin as the master table, since it has multiple value for its key. The gender table will be the slave table as its keys are unique. Remember that slave tables must have keys that are unique. We join the two tables by connecting the multi-join box and specifying the foreign key as gender ID in the cast table and the primary key as the gender ID in the gender table. After the join, we now know the gender names instead of codes. Next, we aggregate the data per actor and gender to count how many times they play each gender in specific roles. Next, we use the concat string box by setting the actor name as the partition or group by column and gender name as the column to concatenate. Finally, looking inside the concatenated column, we find if an actor plays simultaneously both male and female roles. Indeed, if the concatenated string contains both male and female, it means that the actor has portrayed characters of both genders. Robin Williams, of course, as Mrs. Doubtfire. The third question is, which movie genre, on average, generates the highest and lowest profit? To answer this question, we need to join the movies and the genre table together. These two tables cannot be linked together directly. We have to use the genre association table in between to link these two tables all together. The multi-join box is very handy for that. It allows us to join all three tables simultaneously in one go. For the first join, we connect the genre association table and the movie tables. The master table key is movie ID and the slave table key is the column ID from the movie table. This join gives us the data of all movies with their corresponding genre. Next, we add another join. This second join is joining the master table on the pin 0 with the table on the pin 2, that is the genre table. The foreign key for this join is genre ID and the primary key is also genre ID. This second join provides us with the genre names for each movie. Please note here that I am writing with a 2 here, meaning that this second join is between my master table and the table connected on the input pin 2, which is the genre table. At this point, we save the output of the join inside a new GEL file named movie genre that we'll reuse later during the course of this tutorial. This will allow us to simplify slightly the resolution of the next question. After the joins, we create a new calculated field named profit by subtracting the budget from the revenue. This gives us the profit for each movie. To compute the average profit per genre, we aggregate the data on the genre name and compute the mean of the profit. Next, we sort the result in descending order. Now, we can see the genre that has the highest average profit. It turns out that animation genre has generated the most profit on average. If you're enjoying this video, I kindly request you to show your support by hitting the like button below. It really means a lot to us. Also, make sure to subscribe to our channel to receive alert whenever we publish new videos on the fascinating topic of data preparation. Your subscription plays a crucial role in our effort to create valuable content for you. Our ultimate objective is to create a series of videos that guide you through the sometimes complex process of extracting value and knowledge from your data. So, many thanks in advance for your help in promoting this initiative. The fourth question is which actors frequently collaborate and appear together in movies? To answer this question, we start by joining the cast table with itself using the movie ID column for both the primary key and the foreign key. This gives us as output a new table where each row contains 2 actors that are linked together because they played inside the same movie. They have the same movie ID. In this case, we cannot use the multi-join box since the primary key in the slave table is not unique, so we use the simple join box instead. Since the primary key is not unique, we choose an inner join with duplicates. We join the tables based on the movie ID key and we add the prefix second to all the column names that originated from the slave table. Since here the master and the slave table are the same table, we simply get as output all the columns for the movie table 2 times. The first time without any prefix and the second time with the prefix second. After the join, we do a little bit of data cleaning. We remove the rows where the actor ID value is the same for both actors. Then we aggregate the data by grouping it by the 2 actor ID columns. As an output of the aggregate box, we count the number of rows for each pair of actors. That represents the number of collaboration between 2 actors. Then we sort the results. We finally find that Adam Sandler and Alan Covert have collaborated in 12 movies together. And in position 7 of the table, we see that Ben Stiller works very often with Owen Wilson. We'll investigate that in more details in the next question. As a bonus, Anatilla has a box named Find Connected Groups that is typically used to find connected groups of people. This box is part of the very advanced network mining suite of tools that is unique to Anatella. It's very easy to use. We specify the column actor ID as the parameter ID node A and the column second actor ID as the parameter ID node B. And we run the box. We see that almost all the actors are connected together in one giant group of almost 54,000 actors. That is 98.7% of all the actors inside the database. From this, it really seems that Hollywood is just a big giant family where everybody knows everybody. Or almost. There is still 1.3% of actors that are in small groups disconnected from the rest. The fifth question: in which movie did Owen Wilson star with Ben Stiller? Let's save the previously joined table of cast movies into a gel file that we name Movies and Cast. Once this gel file is saved, you can simply load it in Anatella whenever you need to work with the pre-joined table. This way, you can continue your analysis or perform additional operation on the data without always repeating the join process from scratch. Let's create two tables. The first one with all the movies from Owen Wilson and the second one with all the movies from Ben Stiller. Let's start with the first table. The first step is to filter the movies that Owen Wilson played using a simple filter box. Add the variable actor name and set the condition to actor name as Owen Wilson. Next, we add a select column box to choose the required column from the filter table. We include the actor name, cast character, movie ID, title, and release date column. Now, let's repeat the same process for Ben Stiller. We load the gel file again, we copy the filter box, and we change the actor name to Ben Stiller. And finally, we copy the select column box. By the way, you can easily copy a box by selecting it and then pressing the Ctrl button while dragging and dropping it to a new location. Now that we have our two tables, we can play with them. Let's start by computing the difference between the two movies lists. To do so, we use the simple join box. We select the A minus B join. It doesn't matter if you choose B keys are unique or not. Let's run the process, but we encounter an error. I see the issue. We need to sort the data first. Let's sort it by movie ID. We can copy the same sorting box to the second pin. There we have it. Here are the 29 movies that Owen Wilson played without Ben Stiller. The sixth question is, in which movie did Owen Wilson and Ben Stiller did not appear together? To answer this question, we can modify the type of join in the simple join box. Instead of the I minus B join, we now select the XOR join. This gives us the movies where Owen Wilson and Ben Stiller did not appear together. Let's observe the result. In the output, you can see that many columns are filled with nulls. When Owen Wilson played a role without Ben Stiller, the right side of the table shows null values and vice versa. Let's take a step back and look at the bigger picture of this concept. Let's change the join type again. This time, we select a full author join. With the full author join, we can see the complete picture of the data, including both matched and unmatched rows. Let's look at some example. In the row number 1, Owen appeared in Armageddon without Ben, resulting in the right side of the join being null. In the row number 4, both Owen and Ben appeared together in Meet the Fockers, so both the left and the right side are filled with data. Lastly, in row number 6, Ben played in Madagascar alone without Owen, leading to the left side of the table containing nulls. From the full author join, we can obtain all the other join by applying different filters. For example, if we filter on the first actor being not null, we obtain a left join. This gives us all the movies in which Owen played, including some that he played without Ben Stiller. If we filter on both the first and the second actors not being null, we get an inner join. These are the 11 movies that Owen and Ben played together. If we filter on the second actor being null, we get the A minus B join, meaning the movies where Owen appeared without Ben. And finally, if we filter on the first actor being null or the second actor also being null, we get the XOR join, just like in the sixth question, representing the movies where one actor appeared without the other. For the seventh question, we'll play a little game. Let's assume that Frank and Sabrina wants to have a movie night. Frank prefers the highly popular sci-fi movies, while Sabrina prefers highly voted animation. They need to decide on a combination of two movies to watch for the evening. Let's help them to find the best pair of movies. How will we solve this puzzle? I propose to start by making a table with all the pair of movies that are possible. One of the two movies inside the pair must be a science fiction movie and the other one must be an animation. To create all the pairs, the first step is to create two tables. Each table contains half of the pair. Let's start by creating a table with all the sci-fi movies that we know of. Let's restart from the table from question 3. Inside this table, we have the exact genre for all the movies. This way, we have all the necessary information. Next, we apply a filter to only select the sci-fi genre. We use the filter genre is science fiction. We do the same for the second table about animations, except that we use the filter genre is animation. Now, to generate all possible combinations, we simply perform a cross-join between our two tables. This creates a large table with around 125,000 rows, since there were initially 535 science fiction movies and 234 animation movies. It's important to be careful when using a cross-join as it can create huge table. To reduce somewhat the size of the table that comes out of the cross-join box, a good practice is to reduce as much as possible the size of the two input tables. This is why we add a select column box here and we only select 3 columns, the movie ID, the title, and the popularity columns. In the same idea, we also add select column box here. Now comes the exciting part. We calculate a global score for each pair by multiplying the popularity score and the vote average score. The higher the global score, the better the movie pair for Frank and Sabrina. To find the best global score, we sort the table in descending order based on the score. And the winners are Interstellar and Spirited Away. These movies have the highest score, making them the perfect choice for Frank and Sabrina's movie night. In practice, we could have invented a better scoring mechanism, better than a simple multiplication between the popularity and the vote average. Maybe it will be the subject of another video. We'll see. Our final question is, which genre do the actors mostly perform in? To answer this, we need to link together the actors and the genre that they perform in. There are no direct keys that would allow us to directly link the cast table with all the actors and the genre table with all the genre. To link these two tables, we have to go through many intermediate tables. Indeed, the cast table links to the movie table that links to the genre association table that finally links to genre table. That's a long way to travel to finally be able to link properly these two tables. So, we join several tables: the movies, cast, genre association, and the genre table. Let's reuse the table movies and cast that we created previously that directly contains movies and cast information. Let's also reuse the movie genre table that we also created earlier. Don't worry if you see many join boxes. You can check the result at each step after each join to ensure everything is working correctly. For the final join, we use the simple join box with an inner join type where the primary keys from the slave table can have duplicates. We use the movie ID as the key to join the tables. Now that we have all the necessary information, let's aggregate the data by actor name. Next, we select genre name as the output column and calculate the most common genre for each actor by checking the most common modality checkbox. We also want the count of how many times they appear in that genre, and we can have that by checking the count most common modality checkbox. To make it easier to analyze, let's sort the results by our count column in numerical order, with the highest count at the top. Now we have the most common genre for each actor. Will Ferrell plays a lot of comedy. So to solve this final question, we reuse two tables that we created in the previous question. If we want to solve this question without reusing any table computed during previous questions, we'll get this other Anatella graph that just start all the computation from the very beginning from the raw TMDB dataset tables. This Anatella graph contains no less than 4 joins between 5 different tables, just to answer a rather simple question. This example illustrates quite well how join operations are important when searching the answer to analytical question. I hope that we managed to help you grasp all the subtleties behind this concept of join. Let us know in the comment below if you enjoy this video. Also, please give a thumbs up. Thank you for joining me in this tutorial. Don't hesitate to tell us inside the comment below if you have any question about the content from today and how we can improve this training session around data preparation. In the next video, we'll explore more cool ways to play with your data, so make sure to stay tuned for more amazing content from us. In the meantime, I invite you to watch our other cool videos inside the TIMi channel. See you next time!